All right. All right, so let's look at number 5. It says a survey of 1,000 households in the U.S. found that 75% have at least one cell phone. Okay. So the population here, guys, is going to be all households in the U.S. And then the sample is the 100, or excuse me, not 100, but 1,000 households. Okay. And we say that these 1,000 households are sampled. Okay. And then the data is this right here. It's this statistic. The data is going to be essentially whether or not they have at least one cell phone. Okay, so I'm just going to say that 75% have at least one cell phone. So, you know, if you were conducting this poll of these 1,000 households, the data would actually be yes or no responses. And then you would figure out, okay, how many of those yes responses did we get? Well, if we sampled 1,000 households, then roughly 750 were yes responses, and the other 250 roughly would have been no responses. So then we can say that 75%. Okay. So anyway, all right, well, let's look at this next subsection here. A parameter versus a statistic. Okay. So guys, this ties into that concept of a population versus a sample. So a parameter is a numerical description of a population characteristic. Okay. And then a statistic is a numerical description of a sample characteristic. So what you need to take away from this is that a parameter pertains to a population and a statistic pertains to a sample. Okay? So when you hear that word statistics, or you think of a statistic, you're really thinking about some sort of number or numerical description that describes a sample that was taken. Okay? A parameter is some sort of number or numerical description that describes a population. Okay? So let's look at a few examples here. So it says determine whether the following is a parameter or a statistic. So this is going to hinge upon, does this correspond to a population or a sample? So number 6, it says in a recent survey of 250 doctors, 70% said they enjoy their profession. Okay. Well, this is a statistic, guys, because it's a survey of 250 doctors. It's not a survey of all doctors. So because this is a sample, then this 70% is coming from that sample, so it is a statistic. Number 7, the average salary for 70 of a company's 100 employees is $45,000. Okay, this is going to be a statistic as well. And the reason is because it's the average of 70 of these employees, not all 100 of them. So if this was the average salary of all 100 employees, this would be a parameter. This would be describing the population of all 100 employees. But because it's only describing 70, it is a statistic. Okay. All right, and then number 8. The average English ACT score for all graduates was 21.2. So the key word with this one, guys, is all. Okay. So this numerical description right here, the actual average score in English on the ACT, 21.2, This is a parameter because it's describing a population, because it's the average of all graduates, the average English ACT score. So this would be a parameter. And then the next one, the average lifespan of an American male is 78.69 years. This, guys, is, I'm going to say, a parameter, okay? Because this is a description of all males, okay? And this is very easily obtainable because we keep death records, right? Whenever somebody dies, we record how old they were. And so we can look at all of that data, and that data describes the population of all American males. So I'm going to say that this is a parameter as well. Typically we don't know parameters. And that's why we have the field of statistics. Because we try to take a sample, and from that sample we try to get an idea of what the parameter actually is. So if I'm talking about, what is the average salary of a UAPTC graduate, I don't necessarily have to survey every single UAPTC graduate. I could survey just a few, and from that I could get an idea of what the average of all the graduates is. All right, number 10 says, in the U.S., a survey of a few thousand adults with hearing loss found that 43% have difficulty remembering conversations. Okay, well, this is a statistic. The 43% is a statistic because it's talking about a few thousand adults with hearing loss. There's many, many more adults that have hearing loss. So this is a subset of the population. Okay, so that 43% there is going to be a statistic. Oops, and I'm misspelling that. There we go. All right. Well, maybe we can fit this in within the 15 minutes. This last one here, guys, this last subsection, this pertains to the last learning objective up here. The difference between descriptive versus inferential statistics. Descriptive statistics is much like it sounds. It's the branch of statistics that involves the organization, summarization, and the display of data. So it's really just concerned with painting a picture of what's happening, what's going on, okay? Inferential statistics, on the other hand, wants to tell a story. Why is this happening? Why are we seeing these trends in data? Okay, so it's the branch of statistics that involves using a sample to draw conclusions about a population. And then a basic tool that is used in the study of inferential statistics is probability. We're going to talk about that later in the course. Okay. When you think of inferential statistics, guys, think of the word infer. Okay, to infer something. And here's an example right here, or here's a graphic. It says, well, it's entitled Not Online. So it says U.S. adults who do not use the internet by household income. These days, you wouldn't imagine there would be many U.S. adults who are not using the internet. But so let me zoom in a little bit so you can see this better. So if your household income is less than 30%, or $30,000 a year, then 23% of all those households are not online, essentially. And then if the household is making between $30,000 and $50,000 roughly, then 12% of those households are not online. And then you can see this is painting a picture, and the story that this is trying to tell is that as household income goes up, the percentage of households that are not online is decreasing. So that means that as household income goes up, those people are using the internet more. Okay. So lower earning households, they're more prone to not use the internet at all. So, all right, so let's look at the last few examples here. So it says, give the descriptive and the inferential statistic. Okay. So it says a survey of men and women found that 76% of women and 60% of men visited the doctor within the previous year. So the descriptive statistics would be just those. The 76% for women, and then the 60% for men. Okay. Visited the doctor within the previous year. Now the inferential part here is to make an inference from this data. And the inference that I would say is that because the percentage of men that visited the doctor is within the last year is lower than the percentage of women, we could make some sort of inference, and we could say that something like this: men are less likely to visit the doctor. There's lots of inferences we could make here, guys. We could also say that, well, maybe this means that men just simply don't get sick as much, and therefore they don't need to go to the doctor. That's probably not the case. Okay. Now, the inference that I would make is that men are less likely to go to the doctor. But this would be an example of how we can use inferential statistics. Okay, and I think that's actually it. Okay, which makes me think I should have done a better job of partitioning this earlier. But in any case, that's it for section 1.1, guys. We looked at what statistics actually is, the difference between a population versus a sample, the difference between a parameter and a statistic. So remember, a parameter describes a population, a statistic describes a sample. And then we also looked at the difference between descriptive and inferential statistics. Okay. All right, so I'll see you in section 1.2.